We are now looking at exercise 4.6, question 12, further applications. In this triangle LMN, we're told that the sides LM and LN are equal, and these are indicated with these red dashes, and that LM and LN are greater than the length of MN, and they appear to be so. Also, we're told that P is any point on MN, so point P is just there. I'll just move it over a bit. Also, on ML, cut off MQ, so the distance MQ is cut off there, and that is actually equal to NP, and they're indicated with the double dashes in black. And on side NL, NS has been cut off, so cut off NS, and that's equal to MP. So NS equals MP is indicated by the triple green dashes. Now what we have to prove is that angle PQS equals angle PSQ. Now, at the moment, you've got the double dash side in black and the triple dash side in green in triangle MQP, and you also have the same over here in triangle PSN. So it looks almost like, you can almost prove, or it's looking promising to prove, that triangle MQP is congruent to triangle NSP, because you've already got two sides that are equal to each other. We either have to find this third side for SSS, or perhaps this angle down here at angle M. If angle M equals angle N, then we'll have side angle side. Now, from the question, LM equals LN, so therefore the angle at M equals the angle at N, because it's base angles of isosceles triangle. So we can prove that triangle QMP is congruent to triangle SNP. So we're going to proceed with that. First, you need to state what you're doing, in which triangle you're working. So we're going to start off saying in triangle QMP and triangle PNS, first thing we know is that QM equals PN. Now that's been given, so we can write that out. QM equals PN given. We can also see with the triple dash green sides that also that PM equals SN, and we can say that as well. Actually, these are looking a little bit small, so I'll just make them a little bit bigger. And then we can say what we were discussing before, that because LM equals LN, that angle LMN equals angle LNM, because they are base angles of isosceles triangle. So we can say that next. So angle LMN is equal to angle LMNM, base angles of isosceles triangle, LM equals LN. So that is enough to prove that the two triangles are congruent. So I've just put little circles there to indicate that that angle at M equals that angle at N, and we can clearly see that we've got SAS. So we'll make that statement now, that therefore triangle QMP is congruent to triangle, so Q goes along the side with the double dash, if you read it. So QMP, it's along the side with the double dash and along the side with the triple dash. So if we do the same in this other triangle, going along the side with the double dash, it's PN, and then along the side with the triple dash, it's S. So PNS is in the corresponding order of the first triangle. So we need to preserve the order of vertices in these questions. So therefore those two triangles are congruent. Now the question wants us to prove that angle PQS equals angle PSQ. Now those angles will be equal if PQ equals PS, making it an isosceles triangle. So what we'll say is that PQ equals PS, because they are corresponding or matching sides of congruent triangles. So PQ equals PS. And because of that, that means that PQS is an isosceles triangle, therefore angle PQS equals angle PSQ, and that's what we've been required to prove. So we can just write that out as well. So therefore, angle PQS is equal to angle PSQ, and the reason is that they are base angles of that isosceles triangle, because we know that PQ equals PS. And that's it for question 12.